Okay, so continuing on with the weightlifting examples from the earlier exercises, let's now calculate some p-values from those examples. So for exercise 1, what are the p-values associated with your weightlifting results from the 3 preceding exercises? So you can go back up to those exercises, you can refer to the correct answers, and so calculate the p-values associated with these 3 z-scores. And then for exercise 2, identify which of the 3 weightlifting results are statistically significant. Okay, so recall that for the first exercise earlier, for that clean and jerk, you had a score of 100 kilograms, you weightlifted 100 kilograms, and all of the competitors in the competition had a mean of 100 kilograms. So your result was exactly at the mean, which is also exactly at the median for a normal distribution. We've talked about that a couple of times in these live lessons. And so that means that exactly half of the values are above your score as they are below. And this corresponds to the highest possible p-value, a p equal to 1. So the highest possible p-value is 1, and the lowest possible p-value is 0. And we get the highest possible p-value when you have a result at the mean, because any value in the distribution is guaranteed to be above it or below it. So if we use that CDF method, we see that the probability of having a value below a mean of 0, a value of 0, is 0.5. And the probability of getting above that is 1 minus that same score. And so overall, if the probability of getting a score below a z-score of 0 is 0.5, and the probability of getting a score above a z-score of 0 is 0.5, that gives us a total probability of 1. So p is equal to 1. More generally, we can create a function to do this for us. So let's create this p from z method into which we can pass in a z value. And what this does is it calculates what we did here manually in a single step. So it takes 2 times the CDF of the z-score, and we're using the absolute value of the z-score, and you can confirm to yourself that my math here works out and that this will give you the same result as doing it in these 2 steps. So for example, if we now put in that z-score of 0 into our p from z method, we get that p of 1 that we had doing it in multiple steps. So that's kind of the first part of the first answer. Now let's move on to calculating the p-value for the second weightlifting exercise. So remember, in the second weightlifting exercise, you had a z-score of 2. So what's the probability of getting a z-score 2 standard deviations above or below the mean? Well, to get below, the probability is 0.02. To get above, it's 0.02 as well. So therefore, the p-value, the probability that a value is greater than 2 standard deviations below the mean or greater than 2 standard deviations above the mean, is the sum of those 2 separate probabilities. Again, we could have just used our p from z method, and we'd see that the probability of that happening by chance is 0.045. And then following the exact same calculations that we did for both of these exercises already, we can do the same thing for your overall weightlifting score. Remember, you had for the overall competition, when we added together your clean and jerk and your snatch scores, you got a z-score of +4. So the probability of getting a observation 4 standard deviations away from the mean, we can toss that 4 into our p from z calculator, and we see that that is very unlikely to happen by chance. 6.3 times 10 to the negative 5, which is about 0.0000633. So very, very small p-values like this are often reported as negative log p-values, which are much easier to read. So you take that p-value and you make it a negative base 10 log p-value. using this built-in NumPy method log 10. And so yeah, so it's much easier to read these. And what this means is that very large negative log p-values, so as this goes from 4 to 5 to 6, those are orders of magnitude less probable events. So big negative log p-values suggest very unlikely events, and that we have a statistically significant result. All right, so now that we have our p-values for all of the previous weightlifting exercises, which of those are statistically significant? Well, this one is definitely statistically significant. So this p-value is much less than 0.05. So that is definitely statistically significant. So your overall score in the competition is a statistically meaningful observation. And likewise, the probability of your score in the snatch is 0.04, and that's just below our alpha threshold of 0.05. So that also suggests a statistically meaningful observation. So the odds of seeing an observation like that by chance alone, there's a less than 1 in 20 chance of that happening by chance alone. And then finally, for your first score on the clean and jerk, that had a p-value of 1, which is absolutely not statistically significant. 1 is nowhere near being below a significance threshold of 0.05. In fact, it's the furthest we can possibly get from it.